Okay, students. Today I'm going to discuss about some of the easiest techniques, shortcuts used to solve problems in the chapter limits. Okay, most of the results we're using in both CET and JE. All of you know well. If I write limit f of x as extends to a is equal to L, it means as x approaches to a, as x approaches towards a, then the limit of the function approaches to L. This is the limit value. This function is exist only when LHL is equal to RHL. LHL is equal to RHL. Well, LHL is meant for limit f of x as extends to a minus. That is below the value of a. So a minus. In the real line you can see below the value of a. And RHL means limit f of x as extends to a plus. As extends to a plus. That is above the value of a in a real line. If LHL is equal to RHL, then only we can say limit of the function exists. So initially we're trying to solve some of the questions which related to this existence of the limit. I'll take question number 1. They have given limit as extends to 0 mod x by x. Options are option 1, 1, option 2, -1, option 3, 0, and option 4 does not exist. Does not exist. To verify this, I start with LHL. Find LHL first. LHL is limit f of x as extends to a minus. Here function is mod x by x and a value approaches to 0. So I'll use LHL for this. For that I should know the definition of mod x. All of you are familiar. Mod x is meant for minus x for x less than 0, plus x for x more than 0, and 0 for x equal to 0. So definition of mod x you know well. For LHL, as you know, limit extends to 0 minus, so mod x should be extends to 0 minus means below 0, less than 0. Corresponding function is minus x by x is equal to x cancel is equal to minus 1. Similarly, RHL limit as extends to 0 plus. So for x more than 0, function is plus x by x. So x's get cancelled, that is equal to plus 1. So we conclude here LHL is minus 1, RHL is plus 1. Therefore, we can clearly observe here LHL is not equal to RHL. Therefore, answer is limit does not exist. Option 4. Here is one more question. Second question. They have given here function limit extends to 4. Function is modulus of x minus 4 by x minus 4. Option 1, 1. Option 2, -1. Option 3, 4. And option 4 does not exist. Same idea, same concept. We should verify whether LHL is equal to RHL or not. Okay, as we did in the last problem, use same technique, but here function is quite different. That is modulus of x minus 4 by x minus 4. So when you thought of LHL, you know well, limit as extends to 4 minus. See, mod x definition you know, but here modulus of x minus a is there. That is nothing but x minus 4. So for 4 minus below 4, the nature of modulus will approaches to negative, because take one smaller than 4 value, say for example 3, it becomes 3 minus 4. 3 minus 4 is minus 1, negative. Therefore it is minus of x minus 4 in general. For below 4, this is minus of x minus 4. Divide by x minus 4, once again x minus 4 get cancelled, that is equal to minus 1. And RHL is limit as extends to 4 plus. Take one examples of 4 plus, say 5. It becomes 5 minus 4. 5 minus 4 is positive. Therefore it is x minus 4 by x minus 4, that is equal to 1. Once again, LHL is not equal to RHL, therefore limit does not exist. These are the problem which related to the idea of an existence of limit. Next, I'll move on to one more question. Here they ask to find out the value of the limit of a function step up of x they have given as x tends to 0. Step up of x. So options are option 1 0, option 2 1, and option 3 minus 1, and option 4 limit does not exist. So I'll choose for the first part some of the basic functions, because these we must know, the mod x function and step up functions and all. Then I'll move on to some of the important ideas of finding limit value. Okay, step up function is most familiar function, but to solve this you should know another way of defining LHL and RHL. See, LHL is limit f of x as x tends to a minus, definition. I can use for the same definition, h value can be used. You know how? This is limit of h tends to 0 of f of a minus h also represent definition of LHL. Similarly, RHL limit of f of x as x tends to a plus, all of you know well. For this, I can use h as h tends to 0, function is a plus h, f of a plus h. You know well, here h represents the smallest value, the smallest positive value, say 0 0.2, 0 0.3. Likewise, the smallest value can be considered. So f of a minus h for LHL, f of a plus h for RHL. This kind of defining LHL and RHL also very useful in these kind of functions. Say in step up function, I'll take LHL. LHL is limit as h tends to 0 can be used. This definition can be used. F of a minus h. F of a minus h means here function is step up of x. A minus h means a is 0 here. So 0 minus h. Got it? Step up function of 0 minus h. As I said, here h represents the smallest value. 0 minus h represents, say some example, minus 0.2, minus 0.3, minus 0.4, like that. In step up function it approaches to minus 1. All below 0 values, 0.2, 0.3, 0.4 and all represents minus 1. Therefore, this value limit as h tends to 0, I'll write the values of this nothing but minus 1. So outcome is minus 1. Similarly, RHL is limit function is step up of x 0 plus h as h tends to 0. 0 plus h means above 0, say 0.2, 0.3, 0.4 and all smallest values. 0 plus of 0.2, 0.3 and all again gives the same 0.2, 0.3 and all. Therefore, step up function of 0.2, 0.3, 0.4 and all approaches to 0. LHL is minus 1, RHL is 0. Therefore, LHL is not equal to RHL. Limit does not exist. These are the first basic idea of limit by using definition of limit, that is LHL is equal to RHL. Techniques can be used. Okay. Now I move on to another important technique of evaluating limit. We need to evaluate many functions. Usually there is to give a function of the form f of x by g of x. Functions will be limit as x tends to a kind of functions. This kind of fractional functions, the ratios, can be solved by using different technique. First I'll deal with factorization. All of you know this. A technique of factorization means we can easily factorize the numerator and denominator. Numerator f of x can be factorized, g of x can be factorized. Some of the factors usually is to get cancelled, and further you can simplify directly approaching the value of x to the approaching with given value, say a in general. Then we can easily evaluate the limits. So one technique is factorization. Okay, but while discussing the results of CET and JEE, I should say the easiest technique of solving this kind of limit is LHL, which is obviously attached with the idea of factorization. because most of the factorization problem can be easily solved by LH rule. Whenever the problem, if it is not easy to solve by factorization, then you can think of LH rule. In some cases, LH rule cannot be used, therefore we can think of factorization. Okay. You know, LH rule, L'Hopital rule means for a function limit f of x by g of x as x tends to a, if it is in a form of 0 by 0 or infinity by infinity form, if it is in the form of 0 by 0 or infinity by infinity, then we can differentiate the numerator and denominator separately. Don't apply quotient rule to differentiate, not just differentiating the whole function. It is differentiating numerator and denominator separately as x approaches to a. After differentiating one time, again apply limits, upper limit by, okay, you can apply the limits x tends to a. Again, if it gives 0 by 0 or infinity by infinity, again you have to differentiate second time f double dash x by g double dash of x. Again it gives 0 by 0 infinity by infinity, again you differentiate. Like this process will continue until we are getting the finite answer. Got it? This is an idea of LH rule. Now, some of the problem can be easily solved by factorization. For some of the problem, LH rule is easier. By choosing this technique, we can evaluate the limit. Okay. So here LH rule indicate differentiating numerator and denominator separately only when the given function is of the form 0 by 0 or infinity by infinity form. Okay. Let us move on to some of the examples which will explain easily the evaluation of these two limits. I'll take one example first. Here is a question. Limit x tends to 1, minus 1. The function is x square plus 3x plus 2 divided by x square plus 4x plus 3. X approaches to minus 1. Options are 0, 1 by 2, 2 and minus 1. You can try this problem by using factorization also. I hope x square plus 3x plus 2 can be easily factorized. Sometimes you should verify first of all whether it is in the form of 0 by 0 or not. If it is a direct finite number, if you get from the evaluation, you can replace it. ಅಂದರೆ ನೀವು x is equal to minus 1 v ಫಂಕ್ಷನ್ಸ್ ಕೊಟ್ಟಾಗ some finite value ಸಿಕ್ಕಿದ್ರೆ directly you can do that. No need to go for factorizations or any other technique. Okay. So here when I approach x is equal to minus 1 in the function, you can see minus 1 square plus 1. So it is plus 3 into minus 1 minus 3 plus 2, and this is 1 minus 1 square minus 4 plus 3. Simplify. It is 2 minus 3, minus 1 plus 1 0. This is minus 1 plus 1 0. So 0 by 0 form it is. 0 by 0 form it is. Therefore, I can apply LH rule. Okay. By L'Hopital rule, I differentiate numerator, denominator separately. Differentiation of x square is 2x. Differentiation of 3x is 3. Differentiation of 2 is 0. Right? Differentiation of x square is 2x. Differentiation of 4x is 4. Differentiation of 3 is 0. So this is as x approaches to minus 1. I'll put x approaches to minus 1. We are getting 2 into minus 1 minus 2 plus 3 minus 2 plus 4. 3 minus 2 1, 4 minus 2 2. So answer is 1 by 2. Option 2 is answer. This is a technique of using LH rule, differentiating numerator and denominator separately. Got it? Now, move on to second question. Limit of x tends to 4, x minus 4 into x square minus 1 divided by x square minus 3x minus 4. X square minus 3x minus 4. X approaches to 4 is the limit. Options are option 1 4, option 2 3, option 3 minus 4, option 4 2. So students, here the function is x minus 4 into x square minus 1 by x square minus 3x minus 4. Either you can use factorization or you can use LH rule. But one small drawback while using LH rule is we need to apply product rule here. Can be done, but in these kind of situations you should see which contains less work done. Because if you move on to product rule, it will take more time compared to LH rule. Compared to factorization, because in LHL product will come while differentiating both numerator and denominator. So I thought of applying factorization. Let us see how it will work by using a technique of factorization. Okay, as x tends to 4 is there, the limit value, limit as x tends to 4, I'll keep numerator x minus 4 into x square minus 1 as it is. Denominator of x square minus 3x minus 4, we can write it as, choose the factors and you come to know the factors of this quadratic expression is x minus 4 into x plus 1. That you can see the normal quadratic factor, on multiplication we should get minus 4, that is 4 minus 4 and plus 1 I'll choose, because which on addition we should get minus 3. So minus 4 plus 1 addition is minus 3. So the factors are minus 4 and plus 1. Factors are minus 4 and plus 1. So x minus 4 and x minus 4 and x plus 1 are the factors. Easily x minus 4 terms get cancel each other. Therefore we left with limit of x tends to 4 x square minus 1 by x plus 1. We can write x square minus 1 as x minus 1 into x plus 1 divided by x plus 1. Again x plus 1 get cancelled. So at last we left with limit of x minus 1 only. As x tends to 4, replace 4 minus 1, that is equal to 3. Option 2 is the answer. So after factorization, x square minus 1 we can write as x minus 1 into x plus 1 divided by x plus 1, x plus 1, x plus 1 get cancel each other. We left with option 2, 3 is the answer. This is the technique of factorization can be used. The technique of factorization. Now I'll move on to one more example. Let us see whether factorization is easier or LHL is easier. That is limit of x tends to 1, 1 minus x power minus 2 by 3 minus 2 by 3 divided by 1 minus x power minus 1 by 3. Option 1, 2, option 2, 1, option 3, 2 by 3, option 4, 0. We can use LH rule, no problem, because differentiation of x power minus 2 by 3, the x power n property can be done. But here also I can think of factorization. Just if I use one simple logic, this denominator term will get cancel easily. ಅಂದರೆ ಇಲ್ಲಿ ನೀವು LH ರೂಲನ್ನು ಯೂಸ್ ಮಾಡ್ಬೋದು ಅಥವಾ ಫ್ಯಾಕ್ಟ್ರೇಷನನ್ನು ಯೂಸ್ ಮಾಡ್ಬೋದು. ಬಟ್ ಡಿನಾಮಿನೇಟರ್ ಅನ್ನು ಒಂದು ಸಣ್ಣ ಲಾಜಿಕನ್ನು ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ಡಿನಾಮಿನೇಟರ್ನ ಫ್ಯಾಕ್ಟರ್ ಈಸಿಲಿ ಕ್ಯಾನ್ಸಲ್ ಆಗಿಬಿಡುತ್ತೆ. ಆಗ ನಮ್ಮ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಈಸಿ ಆಗುತ್ತೆ ಅನ್ನೋ ಕಾರಣಕ್ಕಾಗಿ ಐ ಥಿಂಕ್ ಆಫ್ ದ್ಯಾಟ್ ಫ್ಯಾಕ್ಟ್ರೇಷನ್ ಟೆಕ್ನಿಕ್ ಓನ್ಲಿ. ಲಿಮಿಟ್ ಆಸ್ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು 1, 1 minus x power minus 1 by 3 whole power 2 I can write. Got it? I can write this x power minus 2 by 3 as x power minus 1 by 3 the whole square. Both are same. I can reduce this into the technique of a square minus b square by writing 1 as 1 square. a square minus b square by writing 1 as 1 square. That is 1 minus x power minus 1 by 3 into a square minus b square is a minus b into a plus b. 1 plus x power minus 1 by 3 divided by 1 minus x power minus 1 by 3. This factor get cancel each other. Got it? A minus b into a plus b. A square minus b square. So approaches x tends to 1. 1 plus 1 power minus 1 by 3. So that is cubic root of that term we left. The negative factors get cancel each other. So 1 power minus 1 by 3 is nothing but actually 1 by 1 power 1 by 3 is also 1. Therefore 1 plus 1 is equal to 2. Option 1 is answer. This is the another important problem using the technique of factorization. Here is a one question. This also we can think both the factorization and LHL. So I'll give the question. Limit as x tends to pi by 6 function is 2 sine square x plus sine x minus 1 divided by 2 sine x minus 3 sine x plus 1. Okay. Uh, Here also we can apply LH rule or factorization. Here, since it is a quadratic factor, factorization is easier. So I'll just factorize this. Limit as x tends to pi by 6. I can write this as 2 sine x minus 1 into 2 sine x plus 1. That you can observe clearly when you take sine x common outside. This normal technique of factorizations, when you thought of this factor, say, which on multiplication you should get, a into c, what is that, minus 2, which on addition you must get 1. So let us choose a factor, 2 and minus 1 will be the factor. So let's factorization. Let's factorize 2 sine square x plus 2 sine x minus 1 and all. You simplify, we get this factor. Similarly, the denominator 2 sine x minus 3 sine x plus 1, which on multiplication we must get 2, which on addition we must get minus 3. Choose the factors and simplify. Which on multiplication, isn't it, 2 into 1, and which on addition is minus 3. Okay, if I choose minus 2 minus 1, that's better. Minus 2 minus 1. Let's factorize this. We will get, which on factorization you will get 2 sine x minus 1 into sine x minus 1, which on simplification. So 2 sine x minus 1 is same factors. Let's approach x tends to pi by 6. We left with the 2 sine x plus 1 divided by sine x minus 1. Let's approach the value. Once I will write, it will be clear. X tends to pi by 6. 2 sine x plus 1 divided by sine x minus 1. 2 into sine x, sine pi by 6. How much? 1 by 2 plus 1. Okay. Let's simplify. Divide by sine pi by 6. That is 1 by 2 minus 1. Simplify the value. 2 by minus half is equal to minus 4. Minus 4. To bring it to the numerator. So it is 2 to get cancelled. 1 plus 1, 2. Half minus 1 minus half. To bring it to the numerator. So minus 4. Okay. In the option, they have given this as option. I have not given here. Some of the options can be taken as they given minus 3, 6, 0, and option 4 is minus 4. Option 4 can be considered. This is a way that how we can use factorization technique. Similarly, the same kind of problem I'm going to solve using LHL. Let us see how this will work. See, here is one question. Limit of x tends to tan inverse 3. Got it? And the factors are tan square x minus 2 tan x minus 3 divided by tan square x minus 4 tan x plus 3. Options 2, half, 0, 1. Tan square x minus 2 tan x minus 3 divided by tan square x minus 4 tan x plus 3. It can be solved by using factorization, same as we did in the last problem, and also by using LH rule. Just for your reference, I'll solve this by using LH rule. You know how? I'll differentiate the numerator by keeping this approaching limit value as it is. Differentiation of tan square x, you know well, 2 tan x into derivative of tan x is secant square x minus derivative of tan x is secant square x 2 secant square x. Derivative of 3 0 constant. Derivative of tan square x is again 2 tan x into secant square x, that is your chain rule, minus 4 derivative of tan x is secant square x, derivative of plus 3 is 0 because a constant. Overall you can take secant square x common outside. So we left 2 tan x minus 2, 2 tan x minus 4. Secant square x in the numerator and denominator get cancel each other because which is common both in numerator as well as in denominator. Now directly we approach the value, limit value here, that is limit, let's use the limit value, okay, directly I'll replace 2 into tan of tan inverse 3, 2 into tan of x is tan inverse 3, tan of tan inverse 3 become 3 minus 2, 2 into tan of tan inverse 3, 3 minus 4. How much? 6 minus 2 by 6 minus 4, 4 by 2, 2. Option 1 is answer. This is the way how we can use LH rule to solve this problem. Got it? Answer is 2, option 1. Likewise, we can find out different problems by using both LH rule and factorization technique. In tomorrow classes, again we will discuss few more results of limits because there are many shortcuts in limits chapter. We will discuss one by one with more examples. For these concepts, I'll give some of the homework. You have to solve those problems and recall the results. By that, you can prepare for all kind of exams. Okay, thank you.